Hello, I'm Jordan Bailey. I'm a freelance writer, and I wanted to explain how I got some of the data that I included in a story I wrote for the Maine Monitor on the disparities in Black-owned business income and ownership rate. I did this as part of an assignment to write a feature on the Black-owned Maine directory, and that's why I was focusing specifically on Black businesses. And I found that this was the information I just wanted to include in that story about number of Black-owned businesses in Maine and their economic contribution to the state really wasn't being kept anywhere or gathered in Maine. And so I was looking to other sources. I tried talking to state agencies and different organizations to see if they would have this compiled. But when I was speaking with Ryan Wallace at the Maine Center for Business and Economic Research at the Muskie School at University of Southern Maine, he suggested looking at the American Community Survey, which goes to about 1% of the population a year, and it does include questions on race and self-employment income. So he suggested using the public use microdata which would allow me to look at different variables that weren't necessarily published together in a table in the survey reporting. And so I used the microdata based on 5 years of survey results, or 5% of the population. And the Census spokesperson told me that even though these are small sample sizes, they're not as suppressed as the business surveys. So I was hopeful that I would get what I was looking for. So I used the public use microdata custom table tool, which is here, data.census.gov, and you get to choose /MDAT, and you get to choose your data set. And so I chose the 5-year estimates of the public use microdata, and 2018 is the latest they have for that 5-year estimate. And then you can choose variables. So the variables that I chose were, this is race variables, white, Black, class of workers. So they have lots of options, but one is self-employed, in own not incorporated business, and another is in incorporated businesses. I used both for the count, but for the self-employment income, I only used not incorporated because it didn't provide information for Black business owners of incorporated businesses. And I used this variable, which is self-employment income. So I'll show how I did that. So I choose class of worker. These are you select your variables. Race, Black. I had to do Black and white separately, but I put them together in Excel. And then I'm going to start there to show you how I got the count. Then I select the state of Maine, and then I choose what answers I want from each of these variables. So I want just yes and only self-employed in own business. You can see the rest there. So that shows me that there are 618 estimated, 528 of not incorporated businesses and 90 incorporated businesses with Black owners. And here's the white results. Oh, yeah, there it is. So I got 30,000 for not incorporated. I will just show you what that would be with both incorporated and not incorporated. So that comes to, they didn't give me this is self-employment income. But the count, they'll give me the total, is 67,000. And so for the self-employment income, that's 30,000 that's what I'm comparing to the Black self-employment income because they didn't give a value. I could show you that in the Black data that it doesn't give a value for this. Come on, where is it? There's so much you can get. You can research through this. See, didn't give a value. Then I subtracted the Black self-employment income from the white self-employment income estimates and got a disparity of around 20,000 for Maine. So I did that for every state, and this is what I got. Here's how you would add states. You just simply select them, and I just did that and downloaded the table. I'll show you just a few. So just see, they suppress the data for incorporated businesses in a couple of other states as well. So I just didn't use that. I only used not incorporated, and then downloaded the table. You can download there, and started working with it in Excel or Google Sheets. All right, and by the way, this is adjusted for inflation. I did not do that in the one that was published, but it only added about between $200 and $200 to each of these, and it did not change the order of the state disparities. So it didn't really change the shape of the chart, and you probably wouldn't be able to notice a $200 difference. So sorry about that, but I did fix that here. And then, so there's some caveats Ryan Wallace was talking about with me to using this data. So there's other factors that play a role in self-employment income, such as what industry you're in, your age, your education level. I tried to filter down even further by industry and age, and I was just getting zeros for the Black estimates, so I could not compare. But education level, they did not suppress the data. So I got self-employment income estimates for Black and white business owners for the same education level, except the data was suppressed for GED and doctorate for Black self-employment income. But you can see that this disparity persists in their estimates. The other caveat is that there are small sample sizes. So the Census spokesperson I talked to said that the margins of error are good for state-level geographies and only become problematic for populations under 20,000 in the geography, total population, but that with differing population densities, there could be different margins of error. And that is what I found for Black and white businesses, self-employment income margins of error. So I'll show you how I calculated that. I got a margin of error of 4,886 for the Black estimate and 1,834 for the white estimate. And the Census Bureau claims 90% certainty for their margins of error. And while that's pretty large for the Black estimate, it does still show a disparity. So they made between 7,000 and about 17,000. And that disparity then is somewhere between 12,000 and about 27,000. And so I just wanted to show how I calculated this because it was a little bit complicated. And I just wanted people to know how it was done. And I don't know, it was kind of interesting. So, margins of error are published with the actual tables that come out of the American Community Survey, but not with the custom table tool where you're combining variables from different published tables. So, they do it for you in those cases, but not in the custom tables. So they describe how to calculate the margin of error in this accuracy of the PUMS document, which you can find on the technical documentation page here. I already had everything open, but anyway. Here's the technical documentation, and here's the accuracy document. So page 19 explains it. And here it is. So you need certain variables first before you could do this. The design factor, the base of the mean, which is the count. So the number of businesses, and then S squared. And this looks complicated, but you just go step by step, which I will show you. The first part is this weight times the square of the value. So the weight, so each record in the raw data, which you also need to use, is weighted. So it's not just like they have 30 responses and they add up the sum and divide by 30 and get the sum of the self-employment income estimates or answers and divide by 30. No, they weight each record. And this is where I got stuck. I thought that you had to calculate the weight based on different answers in the raw data, but actually, no, it's just provided in with the sample, with the raw data. Each record has a column of what the weight is. So you go to that technical documentation page, go to PUMS data, go to the FTP site, you choose your year. They have 1 year for 2019, but I didn't use that. Choose the data set, and now you're looking for CSV for comma separated values, and then you want, for this research I'm doing, I needed the P, the ones that start with P, because that's person weight versus household weight. So the self-employment income is based on individuals, and not households. So I look for the Maine in the P section. So Maine would be here. So I clicked that, downloaded it, and opened it. It takes forever to open because it's so huge. I've hidden a bunch of columns in here so you don't have to see everything we don't need. But here you have, it was like 64,000, records. So this is a very large data set. And yeah, there was a lot of columns between here, but I'm just choosing the variables, the columns that I need. So it has the adjusted income column, and that's different for whatever year the sample came from or the record came from. And this is the weight. So they give you how much they're weighting each of these answers. Class of worker, self-employment income reported, and race. I got race black and race white. I just left some just to show you how much data is on here. But there's so much more. And anyway, so then I could, filter for, let's say, let's do a filter, which is how I narrowed it down to the business owners, black business owners. I want black to be 1, which is yes, and class of worker to be 6 for self-employed in not incorporated business. And then it's going to get so much smaller. See, there's not a lot. And so it is a very small sample size right here. But they're weighting them like pretty heavily, for example. I'm not going to question why they weight things certain ways. I, looked into it because I thought I had to calculate it myself. And it's based on like household size and various other questions, like answers to questions. But I'm not a statistician, so I can't really critique that. All right. So this is the data that I'm working with. And then we can go on to the formula again and work with that. So what they're talking about here is the weight times the value, which is SEMP right here, and N is the number of records. We don't need to know that. Okay. So first part, weight times the square of the value. So I did that. So there it is. There's the self-employment income times the adjusted income. This value right here is actually, you have to divide that by 1,000,000 because it's supposed to be 1 point something. They just didn't want to put points in there, so to avoid rounding. All right, so I'm getting that value, weight times the square of the self-employment income. Do that for each record. Then you go down and sum it, get the total. So that's the first part. The second part is the times the value and the weight, sum that for all records and square it, then divide by the sum of the weights. So you're multiplying the weight times the value. Do that for all the records. Sum that. Square that. And then divide by the sum of the weights. So right over here, I've got the sum of the weights, which you'll see is the number that they estimate to be the number of Black-owned businesses. And then here, I'm dividing this number by the weights. So these are all the different numbers we need to do this formula. The third part, sum of the weights minus 1, which is quite simple. All right, so now I'm going to get, this is the S squared value. So I just, you plugged in those 3 parts from the formula. Sorry, this keeps going back and forth. So I got my S squared value. Now I can move on to calculating the standard error, which I need the design factor. Again, I can get that from the technical documentation page here. And you can get the design factors. Oh, yeah, right there. I downloaded that already. So you've got to find Maine. You scroll around and find Maine, and then it says in the accuracy document how to find the design factor, but you look at your variable that you're using, and so I'm using, where is it? Personal earnings income. That is 1.4. And I also just checked this with Census people to make sure I did it right, and yes, I did. So that's 1.4. 95 divided by 5 times the number, which is 528, number of the sum of the weights, times that S squared number. So for my Black calculations, I got this is the S squared, this is the design factor, and that's the base. So here's me working out each step of that equation. 95 divided by 5b is that, times S squared. That times S squared is, see, that. Square root of that previous number, because that's what you got to do. See, square root is that. See, square root. And then times that by 1.4, which is the design factor, and you got the standard error. Standard error is around 3,000. Then you times that by 1.6 to get their 90% confidence margin of error, which is 4,886. So I did the same with white, and like I said, I got a smaller margin of error because they had such a larger sample size. Oh yeah, that got cut. That got deleted. But anyway, I got a margin of error of 1,833. All right. And so is 1.645. That's in there, but yeah. Okay. I'm gonna make sure that that was the same for black because maybe it rounded. Yeah, I had 1.645. Okay. Yeah. So that's how that was done. It was actually pretty fun once I figured out my mistakes as far as finding the variables.